Hello everyone, welcome to SCI-EASE. In this video, I am going to discuss the combination of the resistances or the resistors. Apart from the potential difference, the current of the circuit that depends upon the resistances also. So, in case of the appliances like radio, television or similar things, the two or more resistances, they can be combined together to get the required current. So the resistances, they can be combined in two ways. The first one is in series and the second, that is in parallels. If we want to increase the resistance, then the resistances, they will be connected in series. But if we want to decrease the resistance of a circuit, then the resistances, they are connected in parallels. So, what is the resistance in series? When two or more resistances, they are connected end to end consecutively, they are said to be connected in series. Here in diagram, you can see this is R1 is the one resistance and the R2 is second resistance. So they are combined in series and they will help in increasing the resistance of the circuit. But when two or more resistances, they are connected between the same 2 points, they are said to be connected in parallel. So if we want to decrease the resistance, then they are connected in parallels. Here, this is R1 is the one resistance and this is second. They are connected to the common point A and B. So, then we will do in detail about the resistances in series and the resistances in parallels. Now, first we will do resistances in series. The combined resistance of any number of the resistances connected in series is equal to the sum of the individual resistances. So, if R1, R2, R3, so on, they are the individual resistances, their sum will be equal to the resultant resistance R. Suppose the value of R1 is 2, R2 is 3 and R3 is 5 ohm. Then the total resultant resistance, that will be 10 ohm. Just we are taking the sum. We can have 4, 5, so on resistances and that can be connected in series. One thing I want to tell you, before calculating the resultant resistance from the individual resistances when they are connected in series, we should keep in mind two things. When number of the resistances they are connected in series, then the sum of the potential difference across all the resistances, that is equal to the voltage of the battery applied. And second thing, when the number of the resistances they are connected in series, then the same current I, it will flow through each resistance which is equal to the current flowing in the whole circuit. Now, we will derive the formula for calculating the resultant resistance from the individual resistances. So this is the circuit diagram here we are having three resistances. That is, this is R1, this is R2, and this is R3. And the potential difference across R1, that is V1. Potential difference across R2 is V2. And potential difference across R3 is V3. And I have told you in this point, V is equal to V1 plus V2 plus V3. Now by applying Ohm's law, V by I is equal to R, or V is equal to IR. So V is equal to IR, and V1, that will be equal to I into R1, V2 I into R2, and V3 I into R3. So putting all these values, value of V, V1, V2, V3 in this equation V is equal to I into R is equal to IR1 plus IR2 plus IR3. Now this I is common. So common here, then R1 plus R2 plus R3. Both sides we are having I, so we will cut it. And so R, that is the resultant resistance, that is equal to sum of the individual resistances. R is equal to R1 plus R2 plus R3. So this is the resistances in the series, how we can calculate. Sometimes the numericals, they are there in the exam that is asked. So you should know this formula, V is equal to V1 plus V2 plus V3, and how we will substitute it, and we get, you are to find out the total resistance of the circuit. Then by applying this formula, you can calculate. So I have told you that resistances, they can be connected in series as well as in parallels. We have done the resistances in series. Now this is the resistances in parallel. The resultant resistance, or the combined resistance of number of the resistances connected in parallel, that can be calculated by using law of combination of resistances in parallel. According to this law, the reciprocal of the combined resistance of number of the resistances connected in parallel is equal to the sum of the reciprocals of all the individual resistances. If R1, R2, R3 and so on are the individual resistances, so 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. So it is a reciprocal of the sum of the reciprocal of the resistances. Suppose we are taking the combination of two resistances, and R1, that is equal to 6 ohm, and R2, that is equal to 12 ohm. So 1 by 6 plus 1 by 12, taking LCM 12, 2 plus 1, it is equal to 3 by 12, or it is equal to 1 by 4 ohm. So 1 by R, it is equal to 1 by 4 ohm, and R, that will be equal to 4 ohms. You can write the symbol also. So when number of the resistances, they are connected in parallel, then their combined resistance is less than the smallest individual resistance. So this is very important. I will repeat this once again. When the number of the resistances, they are connected in parallel like this, then their combined resistance 1 by R, that is less than the smallest individual resistance. So here we have calculated 4. 4 is less than 6 and 12. So again, in case of when the resistances, they are connected in parallel, before calculating the formula for calculating the resultant resistance, we should keep 2 things in mind. When number of resistances are connected in parallel, first thing, then the potential difference V across each resistance, that is same, which is equal to the voltage of the battery. And second point, when the number of resistances are connected in parallel, then the sum of the currents flowing through all the resistances is equal to the total current flowing in the circuit. This means I, that is equal to I1 plus I2 plus I3 plus so on. So I have drawn this circuit diagram. Here we have taken 3 resistances, that is R1, R2, R3. And this current I, it is flowing through it. When the total current, and here this is the total voltage V. Okay. Now I1 is the current flowing through resistance R1. I2 is flowing through the resistance or resistor, you can say, R2, and I3, that is flowing through the resistance R3. So this is a circuit diagram when you are to calculate the resultant resistance of these 3 resistances. Now, total current I have told you, that is equal to I1 plus I2 plus I3. I have taken 3 resistances here. So, it is up to I3. Now, by applying Ohm's law, I is equal to V by R. And I1, that is equal to V by R1. And I2 is equal to V by R2. And I3, that will be equal to V by R3. Now substituting the values of I, I1, I2 and I3 in this expression, that is I is equal to I1 plus I2 plus I3, what we will get? We will get V by R, which is the value of I, it is equal to V by R1 plus V by R2 plus V by R3. Here we are taking V as common, both the sides, it's V 1 by R, it is equal to V 1 by R1 plus 1 by R2 plus 1 by R3. So VV, that will be cut, and what is the expression we have got? 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the combined resistance or the resultant resistance, that can be calculated by using this formula. So on the basis of these formulae, for series as well as in parallels, I have just calculated a small numerical also, so that you should understand. So on the basis of this numericals, they are often there. So many expressions, they are there in this chapter. So you write all these expressions on one page. okay, and memorize them. Whenever you will open the book, you go through them repeatedly and they will be on your tips. So I will come with the next video. Thank you.